Welcome back to Chris Those Rocks. We're going to talk today about stratigraphy. Stratigraphy is the geologic field of study of layers of rock. Most commonly, it's used for sedimentary rock. Okay, so the most basic issue with sedimentary rocks and stratigraphy is that sediments are small mineral matter grains that have been transported and deposited. This is relevant because the deposition, the process of depositing, happens over cycles over long periods of time. Imagine, for example, seasonal floods from a river. Every year, those floods will lay down a layer, and then it'll stop, and then another layer, and it'll stop, and a layer, and stop. This will go and create strata that we can use to learn about the environment, timelines, and other things. Specifically, though, today we want to talk about those timelines using Steno's principles of stratigraphy. Steno, Nicholas Steno, who that's not his actual name, but published in Latin, he translated it to it. He had 3 rules of stratigraphy that are actually just kind of common sense, but they give you the framework and the logical understanding to make use of more advanced things. His first one was superposition. The idea that a younger rock will be the layer above an older rock. Okay, this makes sense in the framework of deposition because to put a new layer of sediment down, it had to have something underneath it. Like, otherwise it just keeps falling down. So, every time you put a new layer on, it goes on top of the old one. Fairly simple, but a foundational principle. Haha, foundations. No laughs? Okay. Next up is original horizontality. Bit of a mouthful, but it just means anytime a layer of sediment gets laid down, it's horizontal or pretty close to. This applies more to water transport than to wind transport, but it just means that as stuff flows, it settles down to the lowest point so that it'll fill up to being roughly horizontal. And if you saw anything that was severely tilted, folded, anything like that, that generally means it happened afterwards, after the deposition. Sometimes you get a little bit of sticking along a slope or something, but even then, that will be thickest at the bottom and thinnest at the top. His third principle, lateral continuity, is just that a sediment layer will extend until it meets a solid surface. Okay, that sounds a little confusing, but let's simplify it and say you can only fill a bowl until it hits the sides. It'll spread to the edges. Same thing happens in a lake bed. This sediment will settle to the bottom, filling it up layer after layer, up and up and up, but it'll always end at the sides where it's already a solid mass. You can also have an existing rock face, a cliff where everything past the point fell off, all of this. But it also is useful for telling us that if you can find something in one place, it will have continued until something happened to change it. So you can start telling what an old edge of an environment was, and also where something has changed over time. This leads us into another thing Steno talked about but didn't label as one of his rules: cross-cutting relationships. What are cross-cutting relationships? Well, it's a slightly odd way of saying the relationship between a rock or sediment layer and anything that happens across or through it. This can be a fault that breaks it, lava going and pushing up through it, or some kind of animal tunneling or tree roots digging down into anything just that changes the layer of the sediment after it's been deposited. Cross-cutting relationships are important in this because they can only happen after sediments have been laid down. It's a fairly simple logic. You have to have a thing before a change can happen to it. So, using these four principles, stratigraphers and geologists in general can look at a set of layers, determine relative age, that is, age of one versus another, and find a timeline of when things happen to them, like faulting, folding, volcanoes, all of that. So, four simple principles that build up to you can learn a lot about an environment by looking at a cross-section. Basic, but important. So, there you go.